So we have a cubic curve which varies according to the value of k. We've got a point Q on it, so that the tangent to C at Q has gradient -9. So we've got something like this, and we have a point on it so that the gradient at that point is -9. So that point is Q, the curve itself is C, and so if we want to find what the gradient of the curve is, we're going to have to differentiate. So y is 1 over 9 x cubed minus kx plus 5, which means that dy by dx will be 1 over 9. For x cubed, we bring the 3 down and we knock 1 off the 3, so that's 3x squared. For x, the gradient is just minus k. So it says that the x-coordinate of q is 3, so we have that dy by dx when x is equal to 3 is equal to -9. That means that by simplifying that, so we get a third x squared, that means a third times 3 squared minus k is equal to -9. So if we add the k to both sides, add the 9 to both sides, write it the other way round, we're going to get a third 3 squared plus 9. A third of 3 squared is just 3, so that gives us k equals 12. So part B, find the coordinates of each of the stationary points of C. Well, stationary points are where the gradient is 0. And so we want dy by dx to be 0. So that means dy by dx is 0. So x squared over 3 minus 12 equals 0, which means that x squared is 3 times the 12, adding the 12 to both sides, timesing by 3, that's 36, so that means x is plus or minus 6 by square rooting. And very important to remember the plus or minus. They do give you a clue in the question because they say each of the stationary points. Okay, so when x is 6, y will be 1/9 of 6 cubed minus 12 times 6 plus 5. And you can work that out, or you can pop it into your calculator, and that gives us -43. And when x is -6, then we have y is 1/9 of -6 cubed minus 12 times -6 plus 5, and that comes out as plus 53. So our stationary points are 6 minus 43 and -6, 53. Now, to determine their nature, they want us to do some maths. Now, I've always found this a bit odd, really, because we know, because it's a positive cubic, then the part of the cube on the left-hand side here will go down to minus infinity, and this one will go to plus infinity, so it has to be that way, which means since that's -6 in the x direction and that's +6, then we know actually that this one must be the maximum and this one must be the minimum. And we should know all that from this specification, knowing what the shape of a cubic is and knowing where the stationary points therefore will be. However, they do want us to show which is the maximum, which is the minimum, by using either the second derivative or looking at the gradient either side of the point. We're going to use the second derivative. So, for still part B, d2y by dx squared means differentiating dy by dx. So that's going to give us 2x for the x squared divided by 3. Minus 12 disappears. So, d2y by dx squared when x is equal to 6 is going to be 2 times 6 over 3, which is greater than 0, and therefore we have a minimum. And for a further explanation of that, you can look at the video in this playlist for FMSP3 question 4, and that has an explanation of why the second derivative is greater than 0 for a minimum. So I'm not going to go into it now. And so now we need to consider the other point. So d2y by dx squared when x is equal to minus 6 is going to be 2 times minus 6 over 3. That's clearly going to be negative, and therefore we have a maximum. Now, we already knew that from what I've been saying, but if you wanted to check and you hadn't drawn a little sketch, then by thinking about the shape of the red curve on the screen or just quickly sketching it, that's a way of checking that you've got those two right. Now for part C, we've sort of done a lot of this, but we'd better do a proper job on it. So what do we know? Well, we know where the maximum and the minimums are, but what do they want? They want us to sketch it, clearly labelling the stationary points and the point where the curve crosses the y-axis. So the curve will cross the y-axis when x is equal to 0. And when x is equal to 0, y is equal to 5. So if we just draw our curve, we know it looks something like that. We know that this point here is x coordinate of minus 6, that's got plus 6. So somewhere in between is going to be the y-axis. So we can just draw that in, and then we know that that is at 5. Now we also know that the 6 part of the curve is at minus 43. So that means the axis comes somewhere in between. And this point is at minus 43, 6, and this one is at 53, minus 6. And that's a slightly rotten little sketch, really. But it does show all the points that they asked for. And in fact, I've sort of squeezed it into the corner there. In the exam, I suggest you do it rather larger, and then it'll be clearer. So we're going to have a quick look at the question in a graphical form, because we can, and it's fun. Well, I find it fun, and hopefully some of you do. So this is the function, and this slider gives us the value for k. So when k is minus 5, we get plus 5x because it's minus kx. And that's what the cubit looks like. And if we slide this along, we can see that eventually we get to a point where we've got a maximum and a minimum, and then on it goes. You'll notice also that the axes are differently scaled. So we have a point on the curve at x equals 3, so there it is, x value of 3, and as we slide it along, that moves down. Okay, so if we put a tangent onto the curve at that point, it will look like this, and then we can slide the slider and it will stay as a tangent. Okay, so we want a gradient of -9. So there we've gone into the negative gradients. Now, because of the different scales, it won't look like -9 when we get to -9, but we can see at this point we've got a drop of about -20 and a cross of about 10, so that's at about -2. So if we carry on to the value that we calculated, okay, it's 12. So at that point it's roughly going through 0. So if we go down to where we get to 10, that is around 90. So -90 divided by 10 gives us -9. So there's our gradient of -9. The turning points we can put on. And there they are. There's our -6 plus 53 and our +6, sorry, -43. And we can also see that the curve crosses the axis there at 5. So that was just a quick look at the situation. We can in fact put the first derivative on, and so we see that the derivative is 0 there and there, and here, although I said this is in another video, we can see that the derivative is falling, and therefore the second derivative will be negative, giving us a maximum, and here the derivative is increasing, meaning the second derivative is positive, which matches with a minimum.